Hi, everyone. My name's Yi. I think you got a brief introduction who I am and where I came from. So today I will be the moderator for this session. I actually got the invitation only 2 days ago, which I said, oh, it's really hard. It's not only hard because the topic we're going to discuss. It's also because the time, right? It's right before lunch, so I think people need food to refuel their energy before they can really consume what we're talking about here. So hope you didn't suffer too much before you are able to get to food. I'm very happy to have so many talented minds here that we can share experiences and discuss with the audience here. So we can skip our first step, which is introduction, because Vicky already did a really fantastic job doing that. So by talking about from research to application, with a really appreciation and respect that how research become big elements pushing the innovation through. We want to know, except for that part, how the industry pushed, how the industry helped to putting the technology behind it through could do some really impactful applications that people can daily accessible. So not to start from such big topic, we wanted to hear some of advices or thoughts behind what's you foresee the AI can help people's daily life in what formation of project or services, solutions it could take place probably in the near future, let's see, by the end of 2017 or by early in 2018. Let's start from some place that really near.
Okay, those are excellent questions. So I work in computational creativity. And this is actually going to make a good introduction because the last session, I noticed, ended with this idea that humans are going to be freed of repetitive work and computers are going to take care of stuff we don't want to do so that we can be creative, we can do the interesting stuff. My research community has a very different perspective. It's nice to think that computers can't be creative, but once we start looking more carefully at what creativity is, there is abundant evidence that computers are already being creative, and there is no reason to believe that they can't be more creative and in many ways as creative as us. In fact, creativity over the years has been a moving target, where the moment a computer can do something, we say, okay, that's not creative. This other stuff that only we can do is creative. So even over the next year, I see a lot of progress in computers becoming more and more creative, and definitely over the long term. In my own work, I look at computers being creative with music, so computers coming up with songs, for example, and that's definitely, we're moving on that very, very quickly. Okay.
That's a really good question. I've been working on the applied research in Google, so basically my goal is part of we have some fantastic research idea. We prove it works. So we need to apply those ideas into different products in the Google or inside the Alphabet, So basically, I would think currently those research idea is got very fast to be adopted by different products and even faster. And you can see this trend. And for some big things for AI applied, I would think some like medical health is a big thing. And also like AI for finance is also a big thing. And also like a self-driving car. But those three different areas, they probably would not happen at end of this year, probably in next 2 or 3 years. Yeah, that's my.
When we first began building AI projects, we thought we would be working with companies, tech companies in Silicon Valley, the Ubers and the Googles and et cetera. But what we found is that besides the most, maybe the most prominent, which is self-driving cars, most of the companies we work with are trying to solve problems that are maybe a little bit underneath the surface, but have tremendous impact. So, for example, building systems for robots to be able to inspect oil pipelines or highway infrastructure. Those are the type of very safety infrastructure-oriented things that I think are low-hanging fruit that will come online over the next year or two, which may not sound as exciting as self-driving cars, but will have, we think, quite tremendous impact in the world.
Well, at IBM, we would like to think of AI as augmented intelligence. So it's about augmenting the expertise of humans. So some of the examples that we are working on, for example, take healthcare. Doctors have no hope of reading through hundreds and thousands of articles, journal articles that are being published about any particular disease or symptoms or new drugs that are being brought to the market and how they interact with other drugs and those types of things. So how about having AI types of technologies, reading all of that, pouring through all that unstructured documents and journals and providing insights to doctors on what kinds of symptoms relate to what type of diseases and which kind of drugs are shown to have interactions with what other kinds of drugs, and help doctors, not only the experts, but also those ones that are not exposed to the latest and greatest technologies in remote parts of the world, and help those kinds of doctors with the latest information and help them do their job better. And other kinds of examples, think about legal domain, where computers can do now with AI technologies a lot of research for attorneys in terms of researching the pro and con types of arguments by looking at various kinds of legal documents and also any kind of past cases that are available in public media, and help attorneys prepare for their case and do the legal research for them. Or think about where executives need to really make decisions on whether to acquire a company or not. And they need to do different kinds of analysis on the size of the company, the revenue of the company, and what's going on in the marketplace, and really identify the business opportunities by zooming in into various scenarios and such. And there's a lot of information about all these companies in various kinds of unstructured documents. So again, AI technologies can help executives make these kinds of business decisions by doing a lot of this research and providing various kinds of scenarios and simulations types of things. And personally, my work is about understanding people better from the point of view of their sentiments, emotions, and personality traits and their interests. So if we put all of these kinds of information about people together, we can really help personalize engagements for people, be it in the context of the kind of products that they would be interested in, or the kinds of jobs or careers that they may be interested in, or the kinds of storybooks that a child may want to read. All kinds of things around personalization that can be achieved if we knew the person that these computer systems are interacting with better. And there are so many more examples I can cite in terms of customer care domain, chat bots, and those types of things. So without going into the robots versus humans, there are so many ways in which we can put AI to good use today to augment human intelligence and to help humans do their jobs better.
Exactly. And also just very interesting, and for me and probably for the audience as well, a follow-up question. So down the road, to make so many examples happen, especially for the area that you guys already worked on, what are the surprise you've experienced or discovered, and in the meanwhile, what are the difficulties or bottleneck you've encountered when you make it really into productivization of AI-backed solutions and products? Why are you laughing?
That's a wonderful question. As a professor from the world of academia, it's really surprising how little infrastructure there is in my world to go from research into production. I know that there are exceptions. For example, Stanford very much encourages that. But for the most part, in most universities, the way that the reward system is set up, the way that expectations are set up, most of the work and most of the burden of figuring out the world of business falls on the professor. And so very recently, actually, right now I'm in the midst of taking some of my automated songwriting work, and I want to make that available for people. And that just runs completely in parallel to my research without any direct reward for my job, which has been kind of a wonderful experience to delve into a completely brand new world.
I I think to accelerate the speed from research to application or productionize, I feel like my personal experience, you need to have a very good platform. Of course, I would recommend like a TensorFlow or Cafe or Touch, something like that, because those platforms, if you embrace them, they are open source, and they already have lots of research idea, they proved to be working, so you just adopt it into your product. And of course, you need to have lots of data for the scenario you try to solve for that problem. So data is first, then you have a good platform. Like TensorFlow is already the production ready, the system, so you can easily do research and easily to apply it in your production. Yeah.
As a graduate student, which I was before, I would work on a project, publish the paper, and then move on to something else. And the biggest surprise when moving to production is that it's not enough just to train a model, deploy it, and then walk away. Because the type of objects, if you're building, say, a system to detect dangerous objects in a airport security line, for example, the type of objects that the system experiences changes from winter to summer, so seasonally. So you actually have to, in production, build in systems to monitor the performance of the model as it encounters type of objects changing over the course of the season or in different years or particular high-profile events or high traffic days, and modify the model appropriately or even retrain or build a completely different model. So the type of close interaction with a deployed model in production is one of the biggest surprises that we had when helping customers move from research into application.
From my experience, if we want to move some research idea into production, first question we have to ask ourselves is, whose problem are we trying to solve? And what are their expectations? Because in the world of AI and machine learning, what often happens is that it's relatively easy to build a general purpose model that works and gets to about 70% or so accuracy. Now, whose problem does that general purpose model solve is often questionable. So if you take any general purpose model, let's take sentiment analysis, for example, and you say, well, I have built the world's best sentiment analysis research model, now I want to put this out. The client comes and says, I'm working in financial services, and my customers are calling in specifically with insurance-related questions, and here are the different kinds of terminologies that they use, and you put that model to use, it may not work 70% at 70% accuracy that you trained it on. So first question is, whose problem are we trying to solve? Did we train that model with that domain data, domain-specific data? And so I would say, the second question then is, what are their expectations? If they're expecting 99% accuracy, it's not going to happen on day one unless it is trained. Even if it is trained with a lot of the customer-specific data, getting to 99% accuracy is very hard. So setting those two, once you get past those two, then I would say data, data, data. So it's all about getting the domain-specific data and training them on top of the base models or training specialized model for that particular domain by using the platform and the algorithms that we already have. And that is what it takes to bring these research technologies to market as products. And from my own personal experience, we spend about 80% of our time in acquiring, cleansing, preparing data to train the models. And 10% of the time in testing, validating, and then rest of the 10% on actually algorithms and assuming that the algorithms are ready and available and all of that, right? To bring a research idea into a product, that's kind of the rough percentages. Data is the key, and preparing it and getting that ready is the key. That's my experience.
Yeah, that's very good. Thank you all. And just following on that, everyone is talking about data. Data is super critical and is kind of becoming a bottleneck for a lot of development and solutions. It is true, partially because data is important to deep learning. That's how the machine and the model are gonna trained from. But it's also another perspective we can tell is paths that we are shifting to because of a lot of actions in commoditize the AI. For example, like the TensorFlow, where people can easily use that. So if they are capable of gathering their own data and train on using the framework, that's kind of lower the entry as well as make it possible, right? Similarly, like we got like big names from IBM, like from Intel, they kind of make it easy accessible from different perspective. I'm interested to learn from your own experience and your thinking. What's a commodity of AI from your domain or you approach would give the impact of the whole industry? Not only from how the big company gonna shifting their strategy towards tool, but also for startups, people are running, and what's their future to be hoping for there?
That's a very interesting question. My answer is going to be a little bit perpendicular because I'm in education. And so when I teach my students, unless I'm teaching something like algorithms, which is very foundational, I encourage them to take advantage of systems and tools that are available out there. I think computer science is moving away from a field where we want our students to start from scratch and to know how to do every little component of everything that they're creating, but instead to be encouraged to move forward, to use everything that exists, to put it together, and then to add their own new elements so that they're actually creating something brand new. So it definitely, all these incredible infrastructures have made it much, much easier to create new work, even by students who I only have for 4 months at a time. And of course, in my own research and in now, kind of as we're moving towards a startup, being able to take advantage of, I mean, really a mountain of services that are readily available makes it much faster to go from research to industry.
Today I think we're talking a lot about make machine learning for everyone. That means to get into this area, I'll apply it, try it pretty easy for today, right? So, but the problem is just like the Rama just said that you need to understand what's your problem you try to solve and what's data, and you need to clean your data. Also for model parts, even I totally agree that it's just amount like 20% of your work to for this part, but it still needs lots of tuning, which means you need to understand your problem. You need to understand the model for what's going on, right? It's not like magic. You just try it, it just magically work. It's not like that. So it's still, I mean, my suggestion is for today, you know, we know some kind of model, right? Convolution or recurrent model, they works pretty good, right? But those are just a high-level concept. How to make it work? There are lots of tricks. Those tricks you need to try it out. You need to read some paper. You need to do lots of experiments. So not just like about one idea, then apply it, it just works. So I mean, you need to dig into every part of it, data, the model, the idea behind it. Then finally, you possibly can successfully apply this into your product. Yeah.
I think we've learned that having the framework tools such as TensorFlow is great, but for many of the scientists that we work with and folks that work in industry is not enough. Because the entire chain from developing a model to finally deploying it, you need to, for example, as you had mentioned, run a lot of different experiments, play and manage your data sets in different ways, different ways of pre-processing the data set, and even sharing resources across a large group of researchers. And so, we've been very much invested in building a tool chain that includes frameworks as well, but has that full gamut from tracking experiments and data sets, logging all of your various attempts and hyperparameter searches, and then finally, when you're ready to deploy, have a nice tool chain that allows you to take a trained model at the data center and then push it out onto the edge, so in an embedded device, and do all the necessary optimizations that you need to make it fast enough in production. So that entire sort of end-to-end system and tool chain is something that we're investing pretty heavily in and hope to help industry and startups as well make advances in this space.
I'd like to think of this as multiple layers. The bottommost layer is the infrastructure that you need, the algorithms, the libraries for deep learning, SVM, whatever machine learning algorithms you want to use. And those ones, many folks are developing latest algorithms, and they're getting into all these, scikit-learn, Python packages and Java packages and all that within a matter of 2 years. So there is not going to be a whole lot of differentiation there in the long run. I mean, the research in the area of deep learning algorithms and machine learning has to be there, absolutely there, and that will continue, and hopefully, and that will advance these libraries that are being built that pretty much everybody has access to. Then the next level I think of is these really building block types of AI services that any application developer would need. And those would be things like speech to text, text to speech, natural language understanding types of services, detecting entities, concepts, and relationships in a given unstructured text data, and doing sentiment analysis types of things. And if you want to go a little bit more advanced, understand people, their emotions and personality traits and those types of things. And then the next level on top of this, once you have these basic building blocks, that's when you can actually start building AI applications on top, right? The application could be a chatbot for customer care domain, or a chatbot that you want to deploy in an educational environment, answering questions for students, and so on and so forth. You can think of a bot for that a doctor can interact with, and the legal research assistant bot, and those types of things, right? So that's the third level that I think of. And the bottommost layers are, there is a lot of competition there, and there is a lot of vendors and big companies providing different kinds of AI services, building blocks, and such. And as we get to the higher levels, that's where the industry specificity comes into picture, right? Where you have to really train all these general purpose models with the data that makes these ones work for these particular industries and domains, be it healthcare domain, be it a particular sliver even in healthcare for cancer, or if it's for legal domain and for financial services, oil and drilling domain, and so on. So that's where, again, data becomes the differentiator. There is no commoditization there, because big companies have their data and they want these systems, bots, or any kind of analytical pieces that are being built to work for them with their own data. And so you end up customizing, retraining the models, and specialize and deploy those for these specialized customers. And they want to keep their data and models to themselves, and so you just keep on extending the base models. So that's how I think of it. So there is as we go up the stack, there is a lot of scope for differentiation, and data starts to really differentiate all these, the standard building blocks.
Thanks. The next question I'm going to have, actually, I want to change it a little bit. I want to split it like maybe two groups or three. It's more like one interesting chat we just had even before we step on the stage, like how, I'm going to start with handling, where they talking about those, they from a startup world initially, and they saw people talking about like application utilization maybe for some fancy companies like Uber, like the other things. But very interestingly, they end up with their business serving a lot of traditional industry like oil and the other things. I don't even remember what the industry was. So I would like to hear a little about what's your experience based on the shifting, and what's your mental kind of thinking behind that, and what's the takeout there. And I will follow up with others as well.
Yeah, absolutely. So just for context, I was part of a deep learning startup, Nirvana Systems, that was acquired by Intel about 10 months ago. And as I mentioned, when we first started, we thought we would be working with tech companies, because that's where all the data is. But ultimately, these Fortune 100 or Fortune 500 or traditional companies have very valid value propositions for AI applications. The challenge there is that they have a lot of data, no doubt, But all that big data has to be funneled through this tiny pipeline of human annotation. Because to train these models today, we need humans to go through and put boxes around, rusting pipelines, or put boxes around cars or people. And that's one of the main challenges that we face when we sort of made that transition, is the lack of annotated data. And I guess a lot of our thinking behind moving to more traditional customers is that many of them have systems in place to already introduce many of these algorithms into production. And so it may even in some cases be an easier glide path from POC, proof of concept, to deployment.
And it also works, right? Works pretty well, yeah. And what about you, Rama? IBM has a long history utilizing deep learning, machine learning in general, serving for a lot of industries like medical and other areas. What's your experience? How do you see the trend kind of shifting from traditional to more modern, I would say, some reverse back? What's your experience from there?
Well, for me, from my experience, we have always been, IBM has always been in the business of serving enterprise clients, right? So we work with large companies in financial services, retail, transportation, those kinds of industries. And, we have been traditionally working with those kinds of companies with data insights and analysis and those types of things with structured data, right? With our databases and different kinds of transaction management and analytics on top of the structured data and such. Now, it so turns out that close to 80% or 90% of enterprise data is actually unstructured, right? And that has been untapped until now. So only now, with the advances in machine learning and with cloud technologies that are making it possible computationally to analyze these large amounts of unstructured data that's available, that we are able to tap into that 80% of large chunk of enterprise data that has been left unattended. So now we are able to work with those clients to combine insights from not only the structured data that they were tracking, but with a lot of this unstructured data that they are getting, right? I mean, take oil and drilling, for example. I just take that as an example. You combine that with weather information and seismological information, probably, and different kinds of data, along with things that are coming up about what's happening maybe on Twitter, what people are talking about it, their sentiments about drilling, and take all of that information and start to make decisions around things, right? So when you combine this unstructured data and getting insights from that with the actual enterprise level structured data that's coming, companies can actually make a lot more insightful decisions. I mean, decisions that are based on more meaningful information and can make more well-informed decisions. So we are really excited about that possibility now, and we're, with the second iteration, going back to all our clients and saying, here with our technologies, how about we derive these types of insights and add them back to the more traditional kind of insights that we got from structured data, and the possibilities to improve efficiencies or to enter new markets or to advance their products. For clients, the opportunities are endless. So that's the I would say the new market that these AI services have opened up for enterprise clients.
Yeah, sure.
Hi, so I'm noticing that we've been focusing a lot on machine learning, data science, essentially learning from data using deep learning and similar approaches. So I come from a machine learning background, so that's very much at home for me, and I couldn't agree more that these are incredible breakthroughs that are very important. But I just wanted to bring attention to the fact that we're talking about artificial intelligence in general, which is quite a bit more broad than that. And within the computational creativity community, there is this perspective, which I at first found shocking, that machine learning and these really incredible machine learning tools are only part of the picture. And the idea there is that if we want our computers to be creative, more similar to the way that humans are creative, that we actually need to go back and consider other methodology all the way from the bottom. So a lot of researchers believe that these really amazing machine learning models are not going to be enough to get us to have computers be really creative or really intelligent in the full sense. So that'd be interesting to note.
Yeah, you actually already tackled my next question, like regarding how we've shared like thoughts about how the AI-backed business verticals, how the solutions, we've shared some thoughts from there. There also the other perspective, how the technology as a technology can improve or increase the creativity part, like you said. There's something we could change and impact the existing industry, but there are also the other perspective, it may raise new opportunities and boost creativities, like what you said. Yeah.
I can give a very brief example. Very recently, we started working on lyrics writing to complement my system Alicia that comes up with melodies. And one of the biggest problems you see with applying traditional machine learning to creating, to generation, now not to prediction, to generating something like poetry or stories or lyrics, is that you get really beautiful tiny chunks. Like you could have these really perfect sentences, but it's very hard to get high-level structure. And we took the reflection, there's a reflection model that Rafael Paris came up with, engagement and reflection, and we combined that with machine learning models. And together we were able to create lyrics that have interesting structure from beginning to end, that have an interesting high-level structure as well. So here we go.
And also from Xiaobing, yeah, so behind, as an author or creator of TensorFlow, where the framework, I think, definitely helps lower the barrier where everyone could step in. It may be good or bad for some researchers, but it definitely lower the entry barriers where people can step on top of you people's shoulder and be more creative and building applications. Have you ever experienced or seen some of interesting trends or changes on top of the framework you guys already created?
I think, currently TensorFlow has a very great community, and lots of the contribution come from outside. So, in this community, lots of idea about deep learning or more like other traditional machine learning comes out every day. So you can say as a framework, it's like growing, outgrowing. How you can think about currently we want to make it faster and more scalable and for distributed and more easy to use for researcher and more ready for real productionized, right? So you can think there are lots of those different platforms. And I think basically as a platform, there are two main goal or direction need to solve. One is for research perspective, you need real flexibility. You can come up with, try every idea, like reinforcement learning, unsupervised learning, whatever. And another side, just productionize. So when we're talking about production, we were talking about data scale, right? Our performance. So as a platform, it need has some like it needs to satisfy both directions. So I think overall, I don't have a specific direction where TensorFlow is going, but those two directions we need to like keep in mind and try to solve all the problem. Yeah.
Thank you all. I think it's already lunchtime. Thank you for sharing all the thoughts and thank you for your time.